Welcome. So we have a busy schedule today with both frontal lecture and presentations, and hopefully some time to do our own gaming as part of this learning of insights about climate cooperation using simple economic experiments. So this is where we left it off when talking about the inequality game, which we saw that is greatly susceptible in terms of cooperation level, in terms of avoidance of the simulated dangerous climate change, whether we have or not the ability to communicate among the group. Remember, it's groups of 6 players. Half were endowed with a larger amount of money. The remainder 3 were had to invest 3 times in the previous 3 inactive rounds. Hence, they were.
Can you get closer to the microphone?
Yeah, sorry. Must be something with the acoustics in this room. Better?
Yeah.
Okay. So this is where we left it off. Of course, one of the things that I stress is that this kind of simple games still does not capture many real-world salient features of catastrophic climate change, including gradual damages and the knowledge or lack of thereof about the location of the threshold. So it is a rather stark coordination game, which in a way makes it a little bit easier to solve, because we know where the problem lies and we know what should be done, and it's very salient. You have to get to 120 euros in order to avoid with certainty that threat. Now, let's revisit the same framework, but instead using perhaps a more realistic environment in which there's some degree of threshold uncertainty with respect to the goal of avoidance of the public bad, so to speak, of dangerous climate change. This actually connects to a related literature that studies theoretically public goods game provision under threshold uncertainty. And the results of this theoretical work is that uncertainty on the location of the threshold tends to reduce contributions. That makes intuitive sense, since we, in a situation of uncertainty, the coordination game aspect is less salient and less clear. So you're removing that coordination mechanism to some extent. This has been looked at in different games than the one we're going to see, focusing on gambles, so gambling under uncertainty, and a literature that connects to the work by Ellsberg that we saw in the earlier lectures about ambiguity and its perception. So this should be familiar because it's a very similar setup from the one we saw yesterday. There's again groups of 6 players. This time we do away with the inequality in endowment, so we're back to the symmetric environment, which should make it simpler, right? Everything else equal, as we have seen in the Milinski game. However, since we want to disentangle the role of uncertainty and ambiguity, it's probably better to start off with the simplest possible game. So the baseline or control treatment is again one where the threshold is known with certainty. That serves as a reference for the other 2 treatments. The other 2 treatments feature instead respectively risk in the sense of a known distribution around possible thresholds. In particular, it was implemented with the uniform distribution, so each threshold centered at 120, so in expected terms, we're still at the same level. It's just that it could be more or it could be less. Each threshold in the range we explored is equally likely. And so that, again, experimental is important because you want your treatments to be comparable. So you want only one thing to change at a time. So the baseline treatment, there's no uncertainty. In the uncertain environment, you want uncertainty, but not in a biased way, right? If we were to have implemented uncertainty, but with an expected threshold of, say, 100 instead of 120 or 140 instead of 120, then it would have been difficult to establish what was causing the effect, so your causal implications. Again, players could make proposals, this time at the very start. Remember, there's no longer any inactive round, so round 1. And again, halfway through at the beginning of round 6. The way the actual threshold was established or implemented, since there was uncertainty and it was probabilistic, at the end, one of the subjects was asked to volunteer to come in front of the other subjects and select from an urn with different threshold numbers inside, and so that would be transparent to everyone else that there was no gaming of the system from the perspective of the experimenters. So what happened? Baseline, it should be a very simple game, right? Because it's a coordination game with no uncertainty. So we see that on average, groups pledged to give just above the 120 threshold. We have standard errors in parentheses, and the actual contributions are pretty much exactly those, if only slightly less than what was pledged, but definitely just above the threshold. So there's perfect coordination, or almost perfect. You see among all groups that partook into the certainty treatment, there was a very limited range of behavior. Some exactly nailed it, 120, others gave just a little more. Remember, to get to 126, which is the most that any group gave in that treatment, it means that there were only, say, 2 players that twice gave more than €2 if everyone else on average was on average giving 120. So that's almost perfect coordination and very little variation, but that is to be expected. Where it gets more interesting is under conditions of uncertainty, and even more so under ambiguity, where the distribution is actually unknown. So under risk, you see, in fact, the pledges were even higher than in the comparable certainty treatment. People pledged to give around 124, and again, this was still high in the second round. Yet average contributions totaled around 100 or a little more, and we see there's a lot more experimentation going on. Some groups sort of did the selfish Nash, but not really, because they still gave about half the amount of the threshold, knowing that this would not suffice. So it must have become apparent at some point in the game that it was a lost cause, but somehow there were still maybe some persistent cooperators that invested. Under ambiguity, instead, we have, again, first proposal being in the same magnitude as in the other treatments. We see already the second proposal, things are falling apart, but still, people are saying, I will contribute enough that we all get to almost 120. But contributions dropped significantly. Note the standard errors increased substantially, which is also observable in the last column with this unlucky group, almost getting there, but just for €2. By €2 margin, they didn't get to the threshold, and others clearly decided to abandon the sinking boat and just gambled their way out by almost giving nothing to the public good. So definitely a negative and detrimental effect on coordination and cooperation in this game under risk, and even more so under ambiguity. Let's have a closer look at these two treatments. Remember, the threshold is probabilistic, so we don't really know, and it doesn't really matter which of the two thresholds are used, because what matters is what people were told and expected. So, well, under certainty, you know, actually this is the threshold. Here we have the percentage of groups that, given what they contributed, would have been above each of these potential thresholds. So if the actually selected one would be only 20 euros, each group in each treatment would have made it. But that is unlikely, of course. It gets more discerning as we increase the threshold. Sorry, let me just check. There's a message. We have a presentation after you, but my microphone doesn't work. It says the only meeting. Yes, yeah, I had muted you because your microphone was very loud before, so I can definitely unmute you. I'll do that later, no worries. Is there another raised hand? It's him. Okay. Yeah, this will be sorted, no problem. Okay, so you see that as the threshold increases, and remember, in expected terms, people knew that, especially under uncertainty, this was the average level that would count. And you see, as we move to the right, we see that under ambiguity, for instance, only 9 groups out of 10 would have made it, with a threshold of 40. That's very low. And we drop more groups and go, so that's a dark shade histogram. The in-between one is the one featuring uncertainty in the sense of having a risky distribution, a uniform distribution over all these thresholds with expected probability, expected threshold of 120. And you see that also as we get to the right, also many groups in under risk did not provide more than, say, 100. Here, 6 groups in 10 would have made it if this was the selected threshold, 4 would have not. And for 120, which is the most important one, only 2 would have made it under risk, and no groups made it under ambiguity. We saw before that the group that gave the most gave 118. Any questions? Okay, so another way to look is the temporal dynamics, right? What happened over rounds, something that we also saw in the Milinski paper. So here we have on the x-axis the number of rounds, and this is the average per person contribution. Remember, if everyone on average gives 2, right? So if we drew the line here, the horizontal line, that would be what would suffice on average to get to 120, which is the expected value of your gambles, if you want to frame it as such. So you see that almost all treatments started off relatively well, although you see the circles are the ambiguity treatment, and you see that they are already below 2, while the other 2 treatments, certainty and risk, started off pretty much at 2 per person. So they were on track. And we already shouldn't be surprised that these guys, the certainty people, manage. Although it's interesting because they initially, on average, this is averaging out all 10 groups that partook in the certainty treatment, but they were falling behind. Around halfway through, at around 5, things were unraveling, but I think possibly also thanks to the second pledge, which took place just before the beginning of round 6, you see they managed to coordinate successfully on an increased level of investment that just compensated the underinvestment in the early phase. That trend is the opposite pretty much for the other 2 treatments, although you see with the risk one, it's somewhat frustrating because they are really trying, and only at the very end do they underperform in terms of investment. But note that they're still giving around 1.5 per person, which multiplied by 6 is not that far off from that 12 per person, 12 per group that is needed at the group level. You see instead, for what concerns the ambiguity treatment, that things definitely go in the opposite direction than in the certainty case. And in fact, after the last pledge, maybe there seems to be some tacit or perhaps even explicit decision to sort of abandon the sinking boat. But again, you have maybe half of the people, given that on average, even in the end, it was €1 per person, that are still trying and contributing probably at least 2 per round. So this is the main result in this new experiment that looks at the role of uncertainty. So let's look now at games that try and make it more salient about the framework for negotiations. So far we have abstracted away from all the complexities and all the bargaining aspects relating to negotiating a deal, but you can also make more complex games that actually introduce features that would be present in the, say, the climate negotiations. So we will now look at 2 such games after having recapped the main findings from the last 3 experiments, the Milinsky, the Tavoni, and the Dannenberg et al. Paper. So one main takeaway, bullet point, is that uncertainty decreases contributions to the public good. That is clear, especially in their situations of ambiguity. The lesson about the proposals is mixed. If you look at the threshold public goods game without uncertainty, we have that proposals do succeed in helping coordination, but that is less often guaranteed in treatments featuring risk and even more so ambiguity. High proposals do not guarantee high contributions, but we have seen, especially in the inequality game, that pledges do often help with the process of coordinating. Especially in the inequality game, although I haven't showed you the data, it turns out that it is very important how the experiment starts, those few initial early rounds. You can imagine in the climate negotiation space, you know, the first 10, 20 conference of the parties, which we have already used up, are crucial because they set the stage for conditional cooperators also to gauge their opinions and expectations about the cooperativeness of the peers. So even if technically you have 10 rounds, and in some cases it is possible to catch up, we've seen it for instance under certainty and under symmetry in the last experiment, in especially when there is uncertainty or when there is inequality. Both things, in a way, if you think about it, even if they're very different, they make the game more complex because they remove elements of coordination, right? It is somewhat clear that 2 per person is the fair share of the burden in the symmetric environment. It is less clear contributors that were forced to give much to the public good early on, so the poor players as opposed to those that were forced to not give, and then they are wealthier. In this case, they may have differing views about the right amount of contributions due to self-serving biases, for instance. That's the inequality that removes this coordination mechanism. And similarly, even if it comes more from nature, in the sense of, say, scientific uncertainty about the effects of climate change or how to get to your goal of, say, 2 degrees Celsius, but that has a similar end result because it makes players less clear about where should they aim. So in these situations, early action is particularly important. Successful groups were those that started off, on average, on the right track. And in the inequality game, which feature these different responsibilities, we have seen that successful groups were those that equalized the burden, meaning that there was almost perfect redistribution, with the rich taking up the biggest part of the effort and the poor taking up a small yet positive part of the burden in the active rounds. Are there questions on these three games? All right, so we then move to larger ones that try to capture these ideas of negotiations, starting with one that I've called here Kyoto Protocol game, because it's very much styled after the coalition formation games, where you have two stages of participation, and one where, say, the more committed countries decide to go ahead and sign an agreement, and then you have the second movers deciding independently on their own level of abatement. Very much in line with observed behavior in the climate commons. So the main question here is whether the establishment of institution in the form of a voluntary coalition of agents that restrict themselves in the use of a polluting technology entice others to follow suit. So this experiment is a little bit more complex in terms of design, but it brings in many features that we have already encountered, both of coordination and cooperation, and it has aspects that are very much geared after climate change, such as, again, the presence of the threshold. Here, this institution should also somewhat help coordination. Here, the institution is this voluntary club or coalition of early adopters of the clean technology, if you want to give it a green technology interpretation. And these coalition moves sequentially. This is known in the economic literature as a coalition of Stackelberg leaders. If you have studied Cournot models and Stackelberg models, the main difference is that in the Cournot model, the move is sequential. In these Stackelberg leaders, you have this timing element, which of course is strategically quite important and can make also theoretical difference in terms of the equilibrium that you expect. And the last ingredient that makes this game a little more involved, or at least more complex, is that of technological spillover. Here the interest is in looking at whether innovation diffuses to the second movers as well. So it resonates with some of the incentives and dynamics that we have encountered so far. So to fix ideas, subjects, although they weren't given this kind of frame, it was unframed threshold public bad experiment, but so we know what we're talking about. Imagine that you, and we will actually play in class a game of this kind, although it will be simpler. Imagine that you are to choose, a technology that is more heavily reliant on fossil fuels, A, versus, so that's the incumbent technology that is cheaper or more productive, as opposed to a new entrant technology such as B, for instance, solar panels, that differs in the sense that it doesn't have a negative externality because it doesn't lead to pumping of CO2 into the atmosphere. However, it's not yet competitive, so it leads to a lower return. So the decision environment is players are given an endowment, E, and they're asked to choose how much of the endowment to allocate to either of these. So in the end, one choice determines the other one by residual. So if you invest in A, then your return is XA. There's a social cost, that's the externality part, which is gradual. We will see what I mean by this. It's, of course, the more people you adopt A, the more the cost. That's the aspect behind that cost CA. And also there's you can think of it as like a pie, a size of the acceptable level of emissions that is safe, beyond which if too many people use too much of technology A, we may enter into the unsafe territory above that threshold, which will impact, again, probabilistically your returns. So RA, the return to technology A, is larger than RB, but the advantage of technology B is that it does not impose a cost on everyone else, including self. But remember, XB, the investment in B, is likely to be somewhat more palatable because of the less palatable because of the lower return from a private point of view. Questions?
I'm sorry, Professor. Can you hear me?
Yes.
But in this case, regarding the investment B, it's just an assumption that there is no social cost. Because in the reality, I mean, it would be also for renewable energy, some social costs on communities and territories, right?
Correct, yes. Of course, in these experiments, you have to simplify things to the bone. So let's just look at carbon as a potential externality. If that is the only issue here, if insofar as it is 100% renewable energy-based, this technology B, then it doesn't have a social cost of carbon attached to it. But of course, reality is more complex. Here we're abstracting away, but you can imagine that you're creating a new market for green, non-CO2 producing technology, and that certainly has negligible social cost from the point of view of CO2 emissions. If you think about jobs being lost in the traditional sector, that is a different story, and then these costs will not be negligible. But the assumption here that one of the two, the renewable green technology, is preferable from a social point of view because it still creates jobs, yet it doesn't pump CO2 into the atmosphere, and even you can imagine, even for those that are worse off because they may lose their jobs, there's some kind of compensation scheme in practice that will help them find another job through retraining or through a financial compensation. So in this very simple environment, there's no negative externality from using B. In real life, of course, it's a little more subtle than that.
Okay, thank you.
Thanks. Okay, so this is the simple decision task, but as we have already said, there are two stages in this game, and we will come back to that. Here's a little ugly equation, but just to fix a bit more our notation. So your payoff, which depends on how much you invest in A and how much in B, is given by the return to either technology times the amount you put in it, so that's RA_XA plus RB_XP, net of the social costs from the externality, which is proportional to the number of people adopting the polluting technology. That's why this is a threshold public bad game, right? Because the A is the public bad. The more you invest in it, the worse for the environment. This is the situation that return if you are below the threshold. Remember that there's some kind of space that we can work with in a safety environment, meaning that we're still allowed to pollute some. We do not have to decarbonize immediately. So it's okay to have some investment in A. But if this is below T, then we're safe, and this is our return. If instead the group invests too much in A, so if capital X A is above T, you see there's this probability aspect and also Q capturing the damage. I think the damage was fixed at 90% of income. What was manipulated was the probability of disaster. So in case you are lucky, that's your 1 minus P, then you again get the returns that you would get if you were below the threshold, but with the probability P, basically you lose almost everything, 90%, if I recall correctly, of your income. So that's a probabilistic aspect. So the threshold public bad gain, that's T, the threshold. In terms of equilibrium and social optimum, what are the prediction? Let's for now abstract from this coalition formation phase that I will describe in a second. The optimum from the social planner point of view would be to not invest in the old non-green technology, and that this of course depends on the way you parameterize the game, but for the parameters chosen, it is optimal to invest, that everyone, all players invest all their endowment in the clean tech. So that's why you get to this pi optimum, which is RB times E. E is the endowment. So this would guarantee that everyone is best off. In terms of what actually the equilibrium from a selfish calculus perspective are, so the two Nash equilibria are Pareto ranked, so they're not identical. The first one, which has a lower bar to denote that it is to distinguish it from the other equilibrium, is simply to split the level of investment in A. So we'll be focusing a lot on A because B is just a residual, right? Whatever is not invested in A, you're investing in the clean technology. So we can just focus on one variable for simplicity. Means that we are just coordinating at the threshold level. Everyone invests in A exactly the amount of the threshold divided by the number of players. That gives you this pi over bar payoff, which is preferable. So under this equilibrium, we invest the least of the two equilibria in A, and we get 2 pi over bar, which is the Nash equilibrium compatible with avoiding the probabilistic scenario. The other, more traditional selfish equilibrium that would emerge also in linear public goods gain is to just do whatever is best for you independent of these social considerations, and it would mean investing all of your endowment in A, right? So you just go for the gamble in a way. But in expected terms, this will lead to a lower payoff. So things would be better if you were here. Note that there is a tension because even the preferable Nash equilibrium is still below the optimum, which would require all society to transition to the clean technology. Yeah?
Nash equilibrium, why do we calculate it like that?
Why does it get to be the threshold divided by n? Let's see if I have the, maybe I can show you the reasoning for once I introduce the coalition, because it, let's have a look at this slide, and if it's not clear, we come back to it. So remember there's these two stages, the coalition formation stage where you're asked whether you want to join the club or not of early adopters, say, that invest in this clean technology. S denotes the number of subjects who sign up to the coalition of early investors in the membership stage. And conversely, N minus S, if N is equal to 7, as will be in the experiment, that would be 7 minus the number of signatories, is the second movers that decide not to tie their hands and prefer to intervene in the second stage and be free to choose their level of investment in A versus B. So what does it mean to enter the coalition or the club? By entering, players commit to a certain pre-specified investment in A, such that, that's why this will become an equilibrium. For any meaningful meaningful club, meaning for any S which is between 2 and 6, if we have 7 players in total, between 2 and n-1. Why are these meaningful clubs? Because more would be the Grand Coalition, everyone is in, less would be basically no one is in the coalition, because there would be only 1 or 0 in the club, and a club of 1 is not a club. So by entering into this meaningful coalition, the game is such that the players were forced to invest actually. Okay, so it actually is a choice between being free to set your own level and being required to invest in a limited amount. I mean, I'll come back to what it means in terms of payoffs, but the idea is it is calibrated in such a way that you are allowing players to invest some in A, which makes sense, you're transitioning away, but you're avoiding the worst part, which is this bit, you know, where it's likely that you go home without any income. And as we have seen also when looking at the threshold public goods game, so here it's a bad, but it's a symmetric case. In that case, the threshold was 120. 120 is also an equilibrium, similar to here T over N. So T over N in the framework we saw before would be investing €2 per round per person, or 12 per round, or 120 as a group. So that the group invests exactly the amount of the threshold is generally a coordination equilibrium in these coordination games, because of the advantage of avoiding the probabilistic losses. So that is true of that game, and it's true of this game here, because any investments below 120 doesn't make any sense in that framework. Remember when some group invested 118, right? That's wasted money, because you don't get to the threshold, you don't provide the public good. Here, conversely, investing just above 120, the threshold, which we haven't seen how much it is, would be really bad, because you, by just being by a little bit over the threshold, you are in the probabilistic loss scenario. That's why these thresholds are generally also equilibria of this game. Why T over N? Because we're reducing complexity by assuming symmetry, that everyone does the same thing. So if everyone, like in the previous game, gives 2, that's the symmetric outcome. Of course, as I've already mentioned for the threshold public good game we discussed before, any trajectory that leads you to just the threshold is an equilibrium, also asymmetric ones. But here I was just focusing on the simple ones. Does it make sense? Okay, so that's for the meaningful coalitions. What about non-signatories? As I said, they're not tying their hands, they can do as they please. And what if the coalition, by somehow tying their hands and curtailing investment in the polluting technology A, also increases the productivity of B? So we wanted to also capture this idea that sometimes there's spillovers to R&D. So in order to do that, there's also treatments that look at actually an increased RB, return to the clean tech, but which is, as you see, proportional to the number of signatories. So this is S times an indicator function equal to either 0 or 1, which is one way we will see the numbers once we plug them in, to make it more higher return to B, the more the number of the signatories. So these are the main ingredients, and from a strategic point of view, which should make sense given what we have said so far, if the coalition forms, then we will have those S signatories, and the returns, if we are just below the threshold, which is the objective if you want to avoid the dangerous climate change part, you would get to this pi hat, which is of course function of the investment in both technologies, And this part here, remember, this is identical to the equation we saw before, except now we have added that spillover in terms of clean technology becoming more competitive. How much more competitive can be also manipulated, and we will do that. So in this case, it should be a little bit easier to achieve cooperation because you are making, you can imagine it's a world in which either due to technological innovation spillovers or because there's a subsidy to the green technology, say, renewable electricity has become more competitive, still more expensive, but more competitive. So we want to look at the evolution of cooperation under these different treatments. Let's talk for a second about the second movers, also known as the fringe, right? Those that are not in the club, that decide to be free to set their level of investment in a second stage. So again, we have to look at meaningful situation. If there are less than 2 in the club, then there's no club, no coalition. For any meaningful S between 2 and n-1, from their point of view, remember, when players, in this case, the second movers, are contemplating how much to invest in A, they have to keep in mind where they are relative to the threshold. So XAS is the amount that is being invested in the polluting technology by the first movers, and this is pre-specified, right? It's just a function of how many signatories there are, and it is done in such a way that you're still below T over N, the threshold. So from the point of view of a single second mover, that's why it's little xan, non-coalition, non-member, he or she will basically contemplate either staying within that space. Here we're assuming symmetry, so we are dividing by the number of non-signatories, n-s, assuming that everyone is doing the same thing among the second movers, and they will just either aim for investing in A just at the threshold, so that's T minus whatever has been invested in A divided by n-s, or if they are of the selfish kind that doesn't want to even bother trying with the threshold, they will just invest all in A. As before, there's 2 possible equilibrium. So a simple case that makes it clear what the incentives are for the fringe is assuming that there are 6 signatories, right, out of 7. So there's only 1 second mover, and so this person is said to be pivotal, right, because he or she will, with this choice of A, will determine whether you are within the threshold or not. So XAN, the investment in A by this pivotal non-fringe member, can be, again, in principle, it could also be to invest all in A, that's your E level. But for this person, actually, it doesn't make sense because it's up to him to stay within the threshold. And the parameters are such that it is preferable, right, to be under the certain situation of being below the threshold. So in this case, there's not even risk of others doing the exploiting defection at the cost of self. So in this very specific case where there's only 1 fringe member, it's comparable to a situation where we have almost all nations doing their part. There's only 1 country left, and by curtailing investment in coal, say, they can succeed collectively in avoiding the threshold for disaster. It would make economic sense also for this 1 pivotal player to not do the overinvestment in A. And then, of course, there's the other polar situation in which everyone is already in the coalition, then there is no fringe, and due to the way the parameters are set up, the fringe members will be required, the coalition members invest just enough to avoid the disaster. Any questions? on, I know it's a bit of notation, but now we will look at numbers, so it should help in clarifying, but if there's something unclear or if you have any comments, this is a good time to ask. Okay, everything is clear, I guess. So let's look at the numbers, and a bit more about the experimental design. So there were 8 rounds to this game, repeated rounds. The number of subjects was set at 7, as I said. Because it's a relatively large group, there was need for quite a lot of participants, subjects that partook into this game, also because there's many treatments, as we will see. The endowment in terms of laboratory dollars was fixed at 50. The return to the clean technology is 6, while the return to the polluting technology is 10, at least in the baseline conditions. Remember, there's an external cost from the polluting technology. That's €1 of damage to everyone. So it's the spillover, the negative spillover. The threshold, the maximum sustainable, say, investment in the dirty technology is 105, which is exactly 30% of total endowment times number of players. So, you know, just to give you a frame of reference, we can still invest, say, 30% of the economy in the dirty technology, but the way to avoid probabilistic disaster is to invest heavily in B. Probability of disaster, should the threshold be overstepped, is 50%. Actually, Q equals to 0, meaning that if you are in the 1 minus P, like the bad part of the 50% toin cost, you lose everything. And remember that I, that is multiplied by the number of signatories to look at a more favorable RB, is either 0%, in which case that's a baseline situation, or 2 or 7%. So when it's 7, it makes it more palatable to invest in green technology. Of course, this is depending also on how many others do so, how many signatories there are. We will see the numbers in a second. So let's look at 2 hypothetical scenarios. On the left-hand side, we have a successful group. By successful, I mean that was able to not go over the threshold for the public bad. This is the maximum sustainable investment in A, which is 105 laboratory euros. You see, these are the first movers, and these are the second movers. Collectively, they can get there. This is pre-specified and related to the number of signatories, and this is up to the non-signatories. Imagine in this other scenario, there's the same number of signatories, but the second movers are more greedy and decide to invest more in A. In this case, they would go over the threshold and they would face that probability of loss, complete loss. Let me see. Okay. Questions? Okay. Maybe, I don't know. Nope. All right, so in terms of stages, in the first stage, individuals are asked whether they want to join or not the club. That's a yes and no question. Of course, they were given information and charts about what would it mean to be in a coalition of 2, 3, 4, 5, 6, and 7. Depending on the choice, if you chose yes, then you are forced or required to invest a given pre-specified amount in A, which is conditional on the number of signatories. If you said no, then you're actually free to set your level of A and B. You're also given quite a bit of information as a second mover. You're told the size of the coalition, S, how much it has already invested. That's important to compute how much space they still have to invest in A. And to make it easier on subjects, we also calculated the distance from the threshold and let them know. And also they know whether RB has increased or not, depending on the number of signatories. Another thing that was manipulated to get at these spillovers is whether they would be captured entirely by the club only. You know, the idea being that, say, in the EU, we are developing this clean technology market, these benefits of R&D stay within the EU only, or in another treatment, the idea that innovation diffuses irrespective of the club. So in that scenario, everyone stands to benefit from it. And then finally, depending on whether the group was at or below or above the threshold, there was a volunteer who would throw the coin to determine whether the group was lucky in case they overinvested in A above the threshold, or unlucky and lost all their income. So let's look at the first treatment. So in this case, there's no benefit from R&D, I equals to 0%. So remember, we're back in the world where RB is 6, I think, and RA is 10. So depending on the number of participants in the coalition, so the club size, 7 is the grand coalition, 2 is the smallest significant coalition, and this is in between. This is the investment that they were allowed in the dirty technology, which again is pre-specified. Then the interesting part is about the choice of the fringe, of the non-members that choose it once they have been given this information, how much has been invested by the coalition. Of course, if you are in a grand coalition, the game actually ends, right? By design, a grand coalition would invest exactly 1 of 5, which is the threshold, and there's no second mover. So the more interesting situations are these more meaningful coalitions here, and they would know, for instance, this is the pivotal case that we discussed in theory before. This is a situation in which 6 signatories move, they have invested 78, and you are the pivotal player. You could invest up to 27 without overstepping the threshold. And this is the corresponding investment not to exceed. So in this case, the two are identical, but this is because there's only one player left. So in this case, actually, it would make sense to not go over 27 invested in A. So this is the baseline condition, sort of the control group. There's 2 treatments, without and with spillover, right? Remember, spillover is about whether it's only appropriated, this benefit to RB by the signatories or not, if it spills to everyone else. You see that this is a small magnitude of technological gain. It's 2%. This is a technology that is not a breakthrough innovation in terms of technological ameliorment of your, say, efficiency in renewable energy use. So you see, the more signatories, the more beneficial it is, because it's 2% times the number of signatories. So of course, the grand coalition would be reaping the most benefit from this technological innovation. But because of the small 2% magnitude, even in that case, the return to B is less than 7, while the return to A is always 10, independent of S. Treatment 2 is the one where these coalitional investments are fully appropriated by S, the club. Treatment 3, instead, everyone, all the group, both first movers and second movers benefit. There's 2 more treatments, again, without and with spillovers, with the higher magnitude. And you see things get more interesting here, because in the back of your mind, you should also consider that it's not just about the R, but there's also the CA, right? The cost, the externality cost, which harms also yourself and everyone else. So for a grand coalition, you're pretty much ex aequo. The 2 technologies are comparable. In fact, the clean technology from a social point of view is definitely superior in this case because of the cost on others. But even if you only care about yourself, you're almost at the same level because the return is almost 9, and it doesn't have that extra cost known as CA due to the pollution part. So, but of course, this is under 7%, and for a grand coalition, when it's only 2 players, the benefit is more modest. You're closer to 6, which is the baseline. Okay, these are the 5 treatments. Let's have a look at performance. Remember, unlike in the previous 3 experiments, here being above the threshold is a bad thing, right? Because it's a threshold public bad game. 1 of 5 is the maximum that is safe to invest in A. And we have all the treatments here. I've put the legend to remind us about what they stand for. This is the baseline where actually there's not even a coalition element. We wanted to see whether having that institution would help even in the absence of these technology externality part. But we see, yes, there seems to be a modest but non-significant effect. The stars indicate whether the difference is significant statistically or not. So if you compare T0 to T1, T0 is just a threshold public bad game of the kind similar to what we saw before, except it's a bad, not a good, but there's no coalition, the 2 stages. If you add the coalition, 83% of the groups instead of 89 went over the threshold, but you see still the great majority. So things are not looking very good. That also interestingly applies to the case of a low 2% technology innovation without the spillover. So this is the scenario in which you have a 2% increase, which is proportional to the number of signatories, but it's only retained by the coalition. So you see these 3 histograms, yes, they are ranked, but they're very similar. This is 81%. Finally, we see some significant effect once we consider T3, which is also only 2%, but in this case, it benefits also the fringe. So that's interesting, right? Because it tells us that even with a modest technological gain, if everyone is allowed to partake in the benefit for the clean technology, not only will we have some gain in terms of potentially more members into the coalition, but that has to be seen. We'll have a slide about that. But importantly, it's likely that this big drop here is driven by the second movers, by the fringe. So they are still not willing to partake, but they see that enough have signed up and they benefit from the fact that it is more competitive now, RB. And so here 68% went over, which means that more than 30% were below the threshold. This is significantly different from all 3 prior treatments. And then we have the last 2, so number 4 and 5 both have the 7% innovation gain. It makes sense, right, that these are the ones where people cooperated the most. But again, it's interesting because this time the spillover seems to have an opposite effect. The one that in general performs best in terms of the treatment is T4, with high 7% return to R&D, but without spillover. So in this case, it's the opposite dynamic than we saw before, because here you see that once you let it spill over, we have a slight increase in technology A adoption. And this is again has to do with 2 conflicting trade-offs. In T4 we will see worked very well because it lured many people, the fact that they knew that the 7% would be proportional to the number of signatories. They were lured into the climate club. And then, yes, compared to this, treatment 5, probably the fringe didn't invest as much in B, but the dominating effect is the one on the size of the coalition. This one is instead a situation in which fewer people probably signed up to the club, but the fringe benefited and then polluted less, but still the net overall effect of these two counter forces is not as positive as in T4. So in order to unpack all of this, let's look at the numbers a bit by treatment. Remember, S is the number of signatories, and consistent with what the story I've given you, the interpretation that T4 high R&D incentive and no spillover led to large coalition. 4.3 people on average decided to tie their hands and sign up. While you see, once you open these benefits also to the fringe, the size of the coalition in T5 goes back to levels comparable to the other treatments, only around 2.5. And this is the effect on total investment in A, which is pre-specified. This is the best that was elicited in all treatments, given the fact that so many people signed up. So that's for what concerns the coalition members, but we have said that the crucial role is also played by the fringe. And again, remember, the important treatments for what concerns the fringe are especially T4 and T2, because these are the ones where they can also reap the benefit of clean tech becoming more competitive. And you see that this is the investment in A, right? So the more, the worse. They tend to be the treatments in which these were least. And of course, I'm using here the average, right? The average among the fringe, because you have to adjust it by the fringe size, is our treatment 2, and to a greater extent, treatment 3, the one with spillover. So there's two counteracting forces when you compare T3 versus T2 and T5 versus T4, the effect on the coalition size and the effect on the fringe level of investment in A. So let's look at group investment in the polluting technology. That's the mirror image of what we saw before. Again, here we have indicated when the changes are non-significant, but we have the same story effectively with investment in A being highest without the possibility to form a coalition, or when a coalition is possible but with no technological gain. And then we have T4, which on average is still above the threshold with some variation, right? That's why we have these error bands. Remember, the threshold is 1 of 5. So some groups made it, some groups didn't, but over the whole data, they were just above the threshold. But this is the treatment in which they got closer to the goal. We have seen the numbers, but if we put it in a graph, this is the size of the coalition. Remember, the possible maximum is 7, and here we have that the largest is in T4, which features high externality and no spillover, and that is consistent with theoretical predictions. Lastly, the second force, driving force, is the fringe investment, and here we have that the fringe was best in T3, which is the one with low technology gain, so only 2%, but with spillover. Not so strong effect in T5, even if the stakes were higher, but still significantly lower than in T4, where there was where spillovers were not allowed. Okay, so I think we're running out of time. Let me just summarize the main take-home from the Kyoto Protocol game, so to speak. Spillovers catalyze cooperation by the fringe on the one end, but they also weaken the incentive to ratify the coalition of the clubs, so the incentives to become a member, that S number. The positive effect on the fringe is stronger when the magnitude of the benefits from R&D in technology B, the clean one, is smaller. That's an interesting effect of technology diffusion. The negative effect on membership, that's the S variable, is stronger when R&D benefits are high, that's a 7% case, which makes sense, right? The more the club stands to gain, especially in the absence of spillover, the more people are induced to sign up to the climate club. So these findings point to the importance of adding R&D to the bargaining table in climate negotiations, something that actually is not done across the board. And the last bullet point, when investments in R&D for technological reasons, for instance, can only provide limited returns, all the parties are actually better off in this simplified setting when followers, the fringe, can also profit from such investments. Any questions on this rather complex experiment compared to the ones we saw before?
Sorry, Professor, can I ask you a clarification very quickly?
Yeah.
But the fact that we consider the T4 the best situation in which there is a smaller difference between the total investment and the threshold is because we are also considering that at the end we want to invest also in the B investment, so in the green energy, or I mean, I don't understand if they are connected or not.
Okay, that's a good point, and yeah, thanks for raising it. So remember that your decision is simply to choose out of that endowment of 50 laboratory dollars in each round, how much do you want to put in A versus how much you want to put in B. So for simplicity, I've presented the data, given that it is a threshold public bad game, that hence it makes sense in my mind to focus on the polluting technology A. I've shown you the graph for A, but you see, you could measure, so what you see here, for instance, with T4, right, is that on average they invested, say, 110, 115 in technology A, the polluting one. What we don't see on top of it is actually what they invested in B. That's a residual. So yes, the goal is to promote investment in clean tech B. Here I've just shown you the data for A, but I could show you an equivalent graph that would be, but I would have to change the story, right? So if we focus on B, the idea is that you want to subsidize investment in the clean technology so that you have enough such that you would fill all the white bit until the line. So the two problems are equivalent in this very simplified setting. And the choice is, what share do you want to invest in the incumbent dirty technology, and what share do you want to invest in the clean one? Does it answer your question?
Yes, thank you very much.
Thanks. Okay, so if there are no other questions, let's take a 15 minutes break before coming back for the presentations. All right. So I've given the presenters of paper 4 the right to upload the slides. So this can be done more efficiently if all three have the privilege, Marco, Reza, Jarvi, to
Ok.
share the slide.
Come facciamo a caricarla?
Vede questa iconcina in alto vicino al tasto abbandona?
Ah, condividi contenuto, ok, sì, l'ho visto. Vediamo, finestra, oppure posso fare direttamente il PowerPoint.
Sì, no, io il PowerPoint così vediamo, vi
Ah,
vediamo.
ok, però deve essere in PowerPoint. Resa,
O PDF anche.
avete anche PDF? Perfetto. Perché l'ultimo è stato caricato così. Ok. Resa, are you here? Resa?
Marco, do you want me to share the slides?
Yeah, it is better because I cannot upload the PDF Resa sent WhatsApp.
Any of you can do it. If it doesn't appear, you know, you just click on cerca nel computer, find it on your drive, and then you can upload the PDF or PPT. You know, if this is very complicated, I can do it for you. Just let's get on with the slides.
Sorry, Professor, just a moment because we edited our presentation and now it doesn't seem to work.
Okay. Shall we then move with group 5 if you're having issues? And then we go back to you next?
Yeah, maybe it's better. So we can find a way to present our slides.
Okay.
Sorry for the inconvenience.
No worries. So we have Sergio, Job, and Carolina. Anyone here? Sergio, Job. Carolina is online.
Here, yes.
Okay, so you guys will do it here, and Carolina, in the meantime, I give you the privileges as well. But for now, so who starts? Is it you guys or her? It's you, yeah. So, yeah. Okay, so then I don't even need, maybe, yeah, we can do it later when Carolina speaks. Okay, you guys want to come here?
Hello.
Yeah.
Can you share?
We're doing group 5 now. You're going next. Okay?
Where I share it in screen share for the Teams?
Reza, we're now doing group 5. You go next. Okay? You three sort out your problems so we don't waste time. Okay? I'm going to mute you now.
I think that is everything's okay. It's PDF file and you can upload it in share you.
Okay, but let's go with group 5 first because we have already loaded up the slides. Okay, we do group 5, then
Computer.
we start with
Yes.
group.
Yes.
Okay.
Yes.
Okay.
You just use the arrows?
Yes, there's no pointer, so yeah, the arrows or the mouse as well.
Go ahead and
Okay. Yeah. Okay. Hi everyone. We are doing our presentation on an article which was about cooperation in the climate commons. So first of all, cooperation, a very central theme in this one, the broad theme, and obviously as we've learned so far, social dilemmas which include the provision of public goods often need some sort of cooperation in order to reach the maximum output when it concerns the society. However, from an individual point of view, it's not always very rational to cooperate. This is a bit of a paradox in there, and therefore there's also a growing amount of debate and literature on the topic of cooperation. Now, for this article, we zoom in on the topic of climate cooperation and natural resources. And we actually find that natural resources and climate cooperation is often very susceptible to free riding, and therefore the most desirable output from a societal point of view is not achieved. And this paper considers certain measures to promote climate cooperation. Now, why is it so difficult to achieve cooperation in the climate field? There are actually two difficulties being pointed out in the introduction of this article. The first one is that the benefits from climate mitigation are enjoyed worldwide, but on the other hand, it's not really, it's regardless of who bears the burden. So if an individual country decides to do a lot of climate mitigation, then still it's very hard for this particular country to get also all the benefits because these benefits are enjoyed worldwide. And another thing is that mitigation mostly benefits future generations, which poses another barrier or dilemma for current generations to invest a lot in climate mitigation because they don't enjoy the benefits themselves. Now, we have seen in the Paris Agreement that there was a new approach. Previously, climate agreements would be mainly top-down, but this one was more of a bottom-up cooperative nature, and this caused more ambitious and cooperative pledges. And the paper again discusses the drivers behind climate cooperation in detail, mainly based on empirical evidence from previous studies.
So traditional economic theory assumes that humans make rational choices aimed at maximizing their economic well-being, therefore focused on a rational self-interest. However, this approach is pretty narrow and ignores external effects, such as, for example, environmental degradation, implying that public goods will be underprovided and commons overexploited in the absence of, for example, private markets or regulation. Social scientists have questioned for long the realism of selfish rationality as a pervasive driver of human behavior, so basing their criticism on either empirical or behavioral or psychological grounds, showing reality and it's portrayed by neoclassical economics, which assumes always a standard reference. So cooperation, for example, has been labeled as one of the anomalies that could not be explained by standard theory. Ostrom, Nobel Prize, studied the issue of cooperation in local environmental commons, providing evidence that Harding's prediction of the tragedy of the commons doesn't need necessarily to materialize, and indeed is only likely to occur in the presence of additional circumstances, such as a lack of norms or open access, for example, to resources. So while these conditions are likely to map larger competitive environments, this is not the case in many local. He also challenged the standard economic theory of collective action, and more specifically, the prediction that individuals do not contribute with any positive amounts to the public. So this called for a new theory, and this theory was based on the recognition that society includes a significant fraction of conditional cooperators, and that they are likely to cooperate as long as they believe that the other players too are trustworthy reciprocators. She also identified some more elements which facilitates contribution to the public good, such as, for example, communication and experience. So the question is, can these findings of Ostrom offer insights for managing global dilemmas, such as like the tragedy of the climate commons? So she argued that the limits that we find of the standard theory in explaining behavior at the local level may also have implications for the global commons, and that norms tend to guide the choice of actions taken in a given context. Therefore, research suggests that individual choices or individuals in general may be willing to contribute to a global public good, for instance, by voluntarily reducing emissions, provided that there is an agreement on the socially desirable behavior and that this behavior is at least partially visible. So individuals may find important to gain reputation by being in line with these norms. So society, as a consequence, that have a significant fraction of trustworthy reciprocators may be particularly prone to address issues such as climate change. Okay. So international environmental agreements have been long model in game theory, and the principle underneath is that the equilibrium number of signatories to a self-enforcing international agreement follows from condition of stability, both internal and external, where no signatory is better off leaving the coalition and where there is no incentive for a non-signatory to join the coalition. So these conditions are necessary because treaties, such as maybe the Kyoto Protocol, cannot be enforced by external institutions with national sovereignty, and therefore must rely on incentives to ensure compliance. So an established insight from these theories is that self-enforcing treaties are unlikely to result in substantial mitigation efforts, especially when cooperation is most needed, so when the potential gains from cooperation are large due to high benefits and high costs. A point to be taken into consideration while talking of climate as a public global good is that emissions are generally considered to be strategic substitutes, meaning that when the marginal damages from global emissions are increasing, a unilateral reduction in emissions by one country will be matched by an increase in emissions in the remaining countries. So this implies that in the absence of a treaty guaranteeing the coordination of mitigation effort, governments will be reluctant to lead due to a loss of competitiveness for the domestic sector or the domestic industry. So scholars are trying to identify and design features which may lead to effective international environmental agreements, and more specifically, increase mitigation efforts. might range from expanding the strategy space via site payments and issue linkage, to introducing minimum participants rules, and also open membership, or also, for example, imposing trade restriction on non-participants. And now I leave the word to Sergio.
Okay, so the paper shows some empirical evidence on the role that the local social norms have in the climate commons. And they talk about three premises that are the peers effect, that is how the presence of a very visible behavioral can change the behavior of the group. Also, how social interventions have a key play in the change of behaviors of a group in an invisible norm, and the role of beliefs, that we're going to talk about trust, how trust make a group's change in the beliefs. So in local social norms influence people behavior, including when their actions affect the climate commons. That's the premise that they have. So in the peer effects, they give us two examples. One, that is the adoption of photovoltaic technology. This experiment was made in different countries, such as Switzerland and United States. And well, they show that with solar panels that can be visible on the purchase or the step roofs, more people are willing to get on board with this project. That in other types of green energy that is not visible, that people are willing to help. In this part, it's also important to mention that the politics play a role, due to the conservative are more willing to get and invest in green energy than other parties. They gave us a second example, that is the adoption of a hybrid vehicle, and they give us two examples, one with Toyota Prius hybrid and Honda Civic hybrid. And what they comment here is that in the case of Toyota, this is the only hybrid vehicle that they have of this model, but in the case of Honda, there is another one that works with the general fuel that we have. In this case, people were more willing to go for the Toyota hybrid and adopt it as the car, that with the Honda, due to it was more visible to see in the in California that Toyota was used for the community. In this case, also the political party plays a role. They talk about the conservative people were more willing to buy and invest even more money in a hybrid car or green energy car than the rest of the parties. They also talk about social interventions. In this case, when the local norms are not that visible, so they talk about the scripted and inductive norms. In this case, the scripted is what about people do, and inductive norms about people should do. So they provide us an example of the consumption of energy in a neighborhood when they have a descriptive norm that is showing how much is the consumption of the household compared with the rest of the neighborhood, and how much it has increased. In the case of the injecting norm, people was receiving an emoticon in the bill saying if the consumption was higher or was lower. In this case, we have a boomerang effect, because people that was having a higher consumption reduced it, but people that was having a lower consumption start increasing the consumption of energy. In this case, what they show in the paper is that for having social intervention and being effective, it is important to have a descriptive norm, but also an inductive norm that creates a balance in the result. They also talk about larger interventions. In this case, they give us the example of a company that is called Power, and they kind of have the same approach of the last example, but in this case, they show that even after years that they start with these reports, it still have an effective in reducing energy consumption in the local neighborhood. In this case, we can show that sharing information about the neighbors in the consumption or in the local norm that we are applying can have an effective result even in a long-term approach, nor in the time that we are applying it. Okay, they talk also about global public good and how we can make it effective if people are asked to contribute to a global public good. And in this case, they talk about the example of population. So they talk about an experiment that they did in Sweden with a group of students where they show that the students were willing to support carbon emission initiatives, and even if that they were providing fake data, people was willing to accept it and to contribute to this initiative. And the last part that they touch is about trust. So they said that it's really important that in a local context to adopt a social norm, that people need to have trust in each other. So they find a positive correlation between countries' level of trust and the adoption of 21 programs. That is the example that they give. That is an initiative to build local sustainable development projects. In this case, they talk that for countries that they have a higher rate of trust in their communities, they are more willing to accept and adopt and contribute to these social projects than countries that had a lower trust in the community.
So, in conclusion, just to recap all the points that have been made by now, on local cooperation and norms, the first point being that although it's not very rational from an individual point of view, we do see that individuals are actually to some extent inclined to cooperate in the face of the global climate change challenge. And in this, a big role is played by local cooperation, which is induced by local social norms. And we see also that when actually this behavior is adopted, this positive behavior change, and it is visible, it also spreads towards the rest of the community and then even to a national or even a global level. However, there is some caution required in the exact specifics on how to induce this social behavior, because when we look at the descriptive norms, we see that descriptive norms that are actually very hard to achieve, that are very ambitious, might backfire because people might think like, okay, this is too difficult to achieve, and then actually a negative behavior change is induced. So policymakers in the end need to be creative in how to adopt and how to create these strategies to kickstart contagion, even when the initial adoption levels of certain behavior are still low. Then shortly on trust, so as Sergio explained, apart from local cooperation, the culture of trust is also very positively correlated with tackling global dilemmas. However, there is a bit of a paradox in this, because to build a culture of trust, you actually also need cooperation. And additionally to that, it requires certainly a lot of long-term investment. So yeah, that's on trust. And finally, the gaps for future research that are denoted by the authors. First one being the working of bottom-up approaches for international climate agreements, which challenges the more top-down conventional assumptions that have been made in previous climate agreements. And finally, also there are gaps for future research on club approaches and schemes for policymakers that leverage reciprocal preferences at multiple scales. And that was it. Thank you for your attention.
Questions? So, what sort of role do political organisations have in changing these localised norms and sort of peer-to-peer interactions?
Well, in this case, what they said is, of course, as organizations, they have the responsibility to and the power to change behavior. But anyways, as Job says, it depends in the way that they are making the policy and applying social norm, because they can get backfire by the distinctive norms.
The questions, comments? People on Teams? Okay, well, thanks again. Well done.
Thank you.
Let's see if we have better luck now.
We should.
Okay, so you should be able to do the magic and upload.
Okay.
Perfect.
Okay.
Floor is yours.
Ready. Good afternoon, everybody. Our paper will be about to see how the private decisions and public policies are shaped by values like personal and societal preferences, explicit incentives, so laws, and social sanctions or rewards like norms. So, next slide. First, let's underline, next, go on. Let's underline the basic framework of our model, which is divided, characterized by agents and principle. Last one basically represents the law, because it decided the incentives and so is a kind of a policy maker, while the agents are, let's say, the people. So in order to represent the agent's preferences, we construct a utility function, as you can see, which for simplicity will encompasses the three key ingredients of an agent decisions, which are the intrinsic motivations of the agent, the intrinsic incentives, and the social or self-esteem concerns, which will be also a little bit explained later. So each agent chooses some discrete action that is indicated by the letter A in the model, the equation, with a resource cost, which is C, and the resource cost will be like time or effort in order to do the discrete action, while y multiplied by a and the general y is the incentive, representing incentive. While on the other hand, v is the agent intrinsic motivation. So, for example, in a firm could be the motivation to work, so like the work ethic of the worker. While in a public context is like the degree of altruism or the pro-social orientation, whether like, for example, the concern for the environment. So also each agent derives a benefit, which is the letter for externality, and is multiplied by the external, the aggregated supply, while the last term mu is basically the reputational payoff, which represents the value of self-image and the judgment and reaction of others as they assess the intrinsic motivation. So, next slide. The principle. We have said there are two main protagonists. One is are the agents, and the other one is the principle. The principle, as said before, is the law, and what it does is that it decides the incentives, which can be, for example, wage in private context or tax and subsidy in public domain. And as said before, the principle may also represent the law, so it can communicate directly with agents, for example, whether by disclosing information, cheat codes, and in general, we assume a well understood notion of what constitutes a good or bad action. and a costless and complete observation of behavior by the principal. So he does all the preferences, he knows all the preferences of the agents. As the main objective, there is the maximization of social welfare. This is the main objective, you can say, of the principal. Next slide, you can see. When, no, go back. Well, U is the sum in equilibrium of all agents' utilities defined by before with A, so on. And their contribution, while lambda is a shadow cost, is a cost of funds for research, like enforcement cost and so on. So this determines the maximization and is the equation for the social welfare, for the maximization of the social welfare. While in the next slide, we can see that in order to calculate the self-esteem, which is important for the agents, it's important to understand the decision-making process of the agents. So how we choose to do an action or instead of another, and how that's imply decision-maker process. So in order to calculate the self-esteem, it's important to understand the decision-making process of the agents. It depend on social multiplier. Like the social multiplier, I like virtue and guilt. So, for example, virtue is the honor conferred by participating, and the stigma, the guilt, is the stigma from abstention. That will be also more clear later on. So, in order to find an interior equilibrium, we solve this fixed point equation that you see in the previous slide, and we put it equal to 0. And the result is that basically the agent intrinsic motivation has to be equal to the cost of the agent's action minus the incentives granted by the principal minus the difference between virtue and guilt of participating for the agents. So next slide. The social multiplier. A general question that is very important in this paper is, for example, more people do the right thing or are thought to do so. Does the pressure on individuals to do the same things rise? And it is linked, this one, to the equation before, which takes into consideration the honor conferred by participating and the stigma from abstention. So the result is that it does not. And the idea is that because honor concerns will dominate when people do the right things are fairly rare. While stigma consideration prevail when only a few deviants fail to comply. And the reason lays in the reputational returns. And if everybody is good, the cost for me to be good is not compensated by the self-esteem gain in choosing the right thing, because everybody does that. So I gain less honor in the action. So the net social pressure is low, and I feel less not doing the good action. So it is important to understand that if the agent's intrinsic motivation, like we could see, for example, a distribution that represents the intrinsic motivation of all the agents, has an interior maximum, the social and the moral pressure has a unique interior minimum, so is on the opposite. And generically, the social pressure minimum does not coincide with the mode of the agent intrinsic motivation distribution, which is important for what we just said before. So next slide is go on. We decide this. Go on. Okay, go on. So I want to also talk about this crowding in and crowding out. It is so interesting, and is about the material incentives like low fines and prices, which can be out by the social the lawmaking here. And we find out that they are not very effective means to spur admirable honor-driven behaviors. For example, military valor, because the reason is that they partially crowd out social esteem. And this is because, for example, if I'm willing to sacrifice my life for somebody else, it will not be determined by, for example, a fine or a price. It's not enough. And on the other hand, for example, a respectable behavior, in which there is no great honor on participation, but great stigma on those who fails. Like a fine works in this case, like in tax compliance. If you do not correctly your tax, the stigma to get caught is very high. So next slide, last one, is go on. Is the modified PIGU, which is called also reputation tax, and it was used to like starting from the original model, so tax model. We know that the planner set incentive, that is Y in the model before, to maximize total welfare, and each individual who contributes at cost C values doing so at a level V, that is intrinsic motivation, and additionally generate an external benefit to society. But also receive the incentive, which is not compensated by the lambda, which are the shadow costs. So this modified prevent this to happen and provide another solution. Zero-sum problem, the zero-sum game of okay. I can go on.
Right, thanks for explaining the model. Next, we talk about persuasion and norm-based interventions. In the paper, it is really dealt with how subjectivity plays into making norms and their effectiveness. Sometimes strict appeals to citizenship or generosity work fairly well. Empirical evidence shows that they are much more effective, however, when leveraged by social comparisons. The first form this can take is making individual behavior more observable to everyone, and the second, on which focuses, consists in altering people's perceptions of what constitutes normal behavior or values in the first.
Do you have another microphone by any chance? Because the voice is a bit broken at times.
Sure.
Thank you.
I hope it is clearer now.
I think so, yeah.
All right, so in the paper we are talking about descriptive norms, which what most people in the community actually do. And then there are the prescriptive norms, what most people in the community approve of. We will see in the paper that when we formalize norm-based interventions, descriptive or what people actually do correspond to communicating with agents about the average compliance, which in turn reflects some preference parameter that they are imperfectly informed about. Prescriptive interventions, however, when you signal about what people should do, it is communicated communicating how people are strongly affected by the problem, or especially about how people are making strong judgments based on the behavior that they should be doing. This entails a lot of social pressure, both directly and indirectly. When we talk about non-strategic revelation, the paper investigates what occurs when the principal cannot prevent the information from leaking. So it is exogenously revealed by third parties. So it characterizes the aggregate response to disclosure, which is of primary interest to the policymaker. But doing so, it somehow understates the extent of the heterogeneity of individual responses, because different individuals respond differently. Next slide. So we talk about strategic disclosure and non-strategic disclosure. So when the principal or the lawmaker chooses either to disclose the information they know or disclose only part of the information they know, so it leads individuals to respond in different ways. In a stable equilibrium, there is more disclosure. The principal is better off under a commitment to disclose. However, here there is a credibility problem, because what would the agents think of the information, whether it's reliable or not, whether it conflicts with what they already know about the behavior of the society. The paper talks about pluralistic ignorance and social proof, because many people may not know the exact prevalence of the law. For example, when you talk about drug abuse or pornography or drinking in the university, many people think that not everyone is engaging in such activities, whereas the contrary is true. So there is a large gap between the um, perceived compliance by the agents in the society and the actual compliance. Then we talk about the expressive function of law. We talk about how law is more than a set of prices, but it conveys a society's behavior or what is considered as acceptable and not. When modeling the expressive law, we must ask ourselves, when should expressive concerns make the law milder, or on the contrary, tougher? The planner tries to maximize this equation, which is here. It is strictly increasing if the interval lies to the left of theta, and it is strictly decreasing if the interval lies to the right. Agents can then invert the policy and infer a true theta as the unique solution from here.
Can I ask what the theta is?
It is the average compliance.
Thanks.
Then we talk about spillovers to behavior, about how individuals interact with each other and what kind of perceptions they form. The individuals have informal interactions when the individual behavior is observed by other citizens, but it is not quantifiable by the government, whereas then there are formal interactions when an individual's behavior conversely is observed and variable by the principle of government, but not by the other private citizens. Then a really interesting argument that the paper puts forward is how the economist's prescriptions are not really accepted by the society, because sometimes economists show policy interventions in which are very quantifiable. They put a price on everything, and the society doesn't really like this, because they prefer to believe that they are a very good functioning civilized society, and they don't want to accept a price-based norm. So we talk about how expressiveness makes the law tougher, because concerns for the society make the law more gentle. Another interesting aspect that is talked about in the paper is how cruel and unusual punishments like public flogging or public punishments are widely attended by the masses, showing a banality for the evil, or how people prefer to see suffering of the others. They can do it, one, because they want the criminals to suffer and they don't want them in their everyday lives, but it also shows a propensity of the individuals to like cruelty, whereas indicating a kind of hypocrisy, because while they want to be in a society of civilized punishments, how does public flogging differ from what happens in jail? It's just that whatever happens in jail is hidden, so the society believes it is somehow better, whereas in some cases it is actually worse. So the paper highlights these kind of discrepancies and what do we need to focus on as lawmakers. I will pass the floor to my colleague from here.
Can you hear me?
Yes, thank you.
And the author mentions four indicators in robustness and extensions. The first one is action space. The 0, 1 assumption yields very sharp results concerning the shape of reputation and optimal incentives. Reputation level will change with shifts in the distribution of preferences, leading to a scope for norm manipulation and expressive law. In particular, whenever the principal has private information about any parameter directly affecting reputation balance, he will weaken incentives so as to economize on their cost by signaling that social payoffs are high. Reputation payoffs talk about most of the paper results were derived under joint assumption that types are distributed according to a single peaked density and that reputational payoffs are linear in the posterior belief about epsilon. This is a natural benchmark, but the result can be substantially generalized. It could be good to note that epsilon refer to agents' intrinsic motivation, and single peak example of single peak is normal distribution. The scope of norms talk about we can entirely already identify several intuitive factors that will also contribute to the emergence of norms or a quest for distinction. A first one is asymmetry in visibility of the social rewards and punishment. In most public goods experiments, for instance, agents can punish free riders but not reward model citizens. This perhaps reflects the fact that in many decentralized interaction, it is cheaper to hurt than to reward someone. Individual social preferences, we have assumed that agents try to signal their commitment to a specific cause, for example, environment, firm, country, to an audience that cares about it. In other contexts, they could instead signal a broader concern for welfare. Experimental evidence shows that agents take into account the eviction effect of receiving of the incentives. A strict liability law forces harm doers to fully compensate their victims. However, strict liability will be suboptimal, thus bringing back a reputation and interaction of law and norms. The final conclusion, the paper main result can be summarized by two multiplier, a social multiplier that speak about measuring how reputational payoffs depend on the frequency of different behaviors in the population, and an informational multiplier reflecting how perception, societal preferences, and the prevailing norms are affected by the policies of informed principles. Optimal incentives take both into account, resulting in two departures from a standard Pico-Ramsey taxation. First, because incentives are shown to generate a crowding out for rare, and second, expressive concept always lead to weaker incentives when the principal's information involves the general goodness of society, and the stronger ones when it concerns spillovers created by agents' behavior. And then at the end, future research is talk about the correlation of norms, law, and social meaning of private-public action offers a vast and promising topic for future research. Thank you.
Sorry for extending our time limit. Our paper was really long and with a lot of models, so apologies for that. If anyone has questions, we'd be happy to answer.
Questions? Yeah, it was a very long and complex paper, so congrats for mastering it. I really shouldn't be the one asking the question. Is there anyone, surely there's plenty of opportunity for confusion if you haven't read carefully the paper. Anyone here or your fellow team's friends that was confused by any of the Greek letters that the speakers put up? Yeah, I think we have lost them. Okay, let me ask a quick question, but again, this is the exception. I want this to be an interaction, not me, telling you things, but an occasion for horizontal learning among us as well, as we would do in a conference. On the empirical validity or the underpinning empirical basis for this theory, of course it's a theory, so it would be unfair to ask to push this too much, but I'm curious. You mentioned, I think Reza mentioned the experimental work behind some of the variables, but do you have a view about how well founded this model is in terms of empirics? Any of you three?
If no one wants to answer, I could go ahead. Apart from the empirical evidence, because the paper makes a lot of exemptions, puts out a lot of assumptions from the academic literature already existing, one thing that I thought personally was maybe verifiable was because lots of papers that mix psychology and economics, they always put the assumption that either the individual complies to the society or kind of tries to distinguish from the society. However, in this paper, they have somehow inorganically built a model that endogenously implies that the individual can both comply and distinguish at the same time, but it depends on the heterogenics of the norms. So putting the question more to the norms of how socially viable they are, and this can be dynamic, so the norms can change. It doesn't have to follow a set parameter, and the individual, depending on case by case, can comply or differ. So I thought that this kind of gives it a bit of credibility.
Very good.
Thank you.
Thank you. Unless Marco and Reza have anything to add,
No, as said before, as Janvi said already, a lot of the empirical work was based on assumptions that were pretty consistent. So, for example, that the lawmaker, the policymaker knows everything basically about the agents. Also, that is pretty inaccurate, we could say, but it's a good model to analyze the dynamics between.
Questions? Let me thank you and see you next week.
Thank you.
See you next week. Sorry for the delay.
You did well. Well done.